Hello students, welcome to my channel eduhub.2m. Today's topic is how your body concentrates urine, the counter current mechanism. This topic is very important in the field of the excretory system, and you can get this topic in various way, like as MCQ, as short question, as long question and all. First of all, we have to understand what is counter current mechanism. You can see here written, it's a master class in water conservation. Means our body needs water to retain. If whatever we drink it goes out from our body, then we will suffer from dehydration. So this counter current mechanism is a master class which helps in the water conservation. By pairing physical loop architecture with active solute pumping, the mammalian kidney achieve unmatched efficiency in fluid regulation. So, in one word, this counter current mechanism helps in the efficiency in fluid regulation. Now, this counter current mechanism is actually a challenge. It balances the water and the waste. What is the vital equation regarding this? Every day, your body must filter toxins while aggressively conserving its most precious resource, water. That means whatever the toxin things we have in our body, these are all mixed with water. So when it goes to the kidney do two things. Number one, it try to excrete the toxin as much as possible and try to retain the water as much as possible, because toxin is not required for our body but water is highly required for our body. To maintain the homeostasis means the normal balance between the fluid and the minerals of our body. The human kidney must solve a complex thermodynamic problem, excreting highly concentrated metabolic waste without dehydrating the organism. Just now I have said that. So what it actually do in counter current mechanism, it eliminates the urea, creatinine and excess ions safely. Number two, retains water dynamically based on hydration level. Number three, operates continuously without conscious regulation. So these are three the main activities which is done in the counter current mechanism, and everything is done to balance the water and the waste product. So the loop of Henle, nature's counter current system. It's a historical discovery we should know, named after German anatomist Friedrich Gustav Jakob Henle, who first identified that specialized U-shaped microscopic structure within the kidney's functional unit, the nephron, which is known as the loop of Henle. It helps a very important part into the counter current mechanism. What is the strategic architecture? The loop of Henle plunges deep into the renal medulla, positioning its parallel descending and ascending limbs in close physical proximity to establish a highly localized concentration field. Means we all know that if we imagine the structure of the nephron, then the descending limb come first, which descends, then goes to the ascending limb, and this descending and the ascending limb, these two produces the loops of Henle, which helps in the counter current mechanism. Now, the counter current multiplier, creating a salty gradient. What is that? It's an osmotic powerhouse, a dual nature of the loop of Henle. That means with one hand ascending limb, another hand descending limb. So it is dual nature of the loop of Henle, works in opposite direction to multiply salt concentration deep into the kidney tissue. Actually, how they do that? Descending limb, highly permeable to water but impermeable to salt. Very important to think, means you have to note it very importantly, that it is highly permeable to water but impermeable to salt. On the other hand, ascending limb is impermeable to water, actively pumped out the sodium and the chloride ion. Here lies the beauty of the counter current mechanism. So it is called counter current, means descending limb which descends down from the Bowman's capsule, that is highly permeable to water but it is impermeable to salt. On the other hand, ascending limb, that after the loop descending limb ends and the ascending limb appears, which ultimately connects to the collecting tubule, that is impermeable to water but permeable to the salt. So water exists passively, leaving concentrated fluid behind. Why concentrated fluid? Because that is totally fill up of salt. Ascending limb, creating a super salty medullary environment because it excretes the salt but retains the water. The role of vasa recta, preserving the gradient. Actually, so far so long we have discussed about the function of descending limb and the ascending limb. Now another structure is there that is called vasa recta, which also helps in the counter current mechanism. The crucial interstitial salt gradient would quickly wash away without a specialized capillary network. The vasa recta acts as a passive counter current exchanger. Descending capillary absorb salt and release water as they plunge into the salty medulla. Ascending capillary return the salt back to the tissue and reabsorb the water to carry it safely back to the systemic circulation. This ensures blood flow nourishes the tissue without destroying the osmotic gradient. So, vasa recta maintains the osmotic gradient. Ultimately, the ascending limb is connected with the collecting duct. So, the final concentration step. What happens? Hormonal fine tuning. The pre-concentrated fluid entered the collecting duct. Where from? From the ascending limb. Running parallel to the established salty gradient, the final water extraction depends entirely on the dehydration level and endocrine signaling. Dehydration level means if there is less amount of water in the body will absorb more water. If there is enough amount of water in the body will excrete the water. And it happens with the help of the endocrine signaling. And now what is the endocrine hormone? That is the antidiuretic hormone, ADH. When dehydrated, your pituitary gland releases ADH. This hormone triggers the insertion of aquaporine, very important, aquaporine water channel in the collecting duct, allowing the water to escape back into the body because the body is dehydrated. So we should restore the fluid. Aquaporine water channels in the collecting duct. So what is the ultimate payoff? How the urine is concentrated? Water conserves 99%. Of the initial filtrate processed by the kidney, nearly all water is systematically reclaimed back into the blood circulation. Okay. Then waste concentration. Toxic waste products like urea, creatinine, we have seen in the previous slides, concentrated up to 50 times their initial blood plasma level for efficient disposal. Then what is the minimum daily output of the toxin? In extreme dehydration, means when the body is almost devoid of water and the kidney have to retain most amount of water, the body can successfully flush daily metabolic waste in as little as 400 milliliters of the fluid. That is very small. Your body's incredible water saving machine. And what is that? It maintains the hemostasis, is maximum the efficacy and the evolutionary trump. Perfectly stabilizes its blood pressure, blood volume and systemic electrolyte balance minute by minute, because all these are dependent on salt and water. Then achieve the dramatic physical concentration gradient using highly localized low energy passive osmotic flow from the descending limb, then ascending limb, then collecting tube. This anatomical adaptation that allowed vertebrate life to leave the ocean and survive on dry, arid land. So everything depends on the counter current mechanism, which involves the descending limb, the ascending limb, the collecting duct, and the permeability of the water and the solids. So please do like, share, and subscribe my channel. Definitely you like the video, I think, because it's very important for your study, and I will share the MCQ and some short questions if possible on this topic, and feel free to comment if you need MCQ and short question. Thanks for watching so long and being with me for long. Please subscribe my channel eduhub.2m. and be with me, and feel free to comment in the comment section so that I can enhance myself and upload new videos, educational videos every day. Thank you so much.